Good evening, everyone. Myself Gautam Sharma. I welcome you all in a Sapience Education. So we are going to solve the physics question, and that is the question from work power energy, and its question is 5.9. Okay. So let us read the question. Okay. Let us read the question. A body is initially at rest, and it undergoes one-dimensional motion with a constant acceleration, and the power delivered to. Okay, so let us do step by step. So what they have given and what they want. So they have given initial velocity is 0 and it undergoes one dimension motion with a constant acceleration. So acceleration is your constant, right? And the power delivered to it at a time t is proportional to. So p proportional to t. So what is the relation between power and is it power proportional to directly t or t to the power x? So we need to find a perfect relation. Okay, see, perfect relation in means what? It means that t to the power x or something we don't know. Okay, so let us do it step by step. So can we write here acceleration is constant? It means that dv by dt is constant. So now tell me dv is equal to c dt. Can we integrate both the sides? If we will integrate both the sides, so we will get velocity is equal to constant into t. From this we have inferred that v is proportional to t. Now apart from this, power is equal to force into velocity. Okay, so you have understood that force is equal to mass into acceleration into velocity v and power p. So mass and acceleration is your constant term into v, and v is proportional to v is equal to ct. Suppose c is your, here it is a c is your c1. So can we write here c into c1 into c1 into time t, and this is equal to power. It means that power, if I will remove all the constants, so power can be written as power is proportional to time t. So our answer is power is proportional to t. So our answer is t. That is second one. I hope you have understood now. That is second option is correct. Okay. Thank you.